Gas chromatograph, flame ionization detector. Chromatography is an analytical technique that separates mixtures into their individual components to be identified and quantified. In gas chromatography, a moving gas carries the sample across a stationary phase. The sample components travel across the stationary phase at different speeds to become separated from one another and their matrix. It is estimated that 10 to 20% of known compounds can be analyzed by gas chromatography. Gas chromatography, flame ionization detector or GCFID, is a very common analytical technique that is widely used to detect, identify and quantitate volatile organic compounds. In gas chromatography, the sample is injected into the inlet where it is volatilized and the representative portion is carried on to the column by the carrier gas. The sample components are separated by differential partitioning in the stationary and mobile phases. The separated sample component elute from the column into the detector and a signal produced. This signal is then amplified and sent to the data system where the chromatogram is electronically constructed. Flame ionization detectors, FID, are the most generally applicable and most widely used detectors. In a FID, the sample is directed at an air hydrogen flame after exiting the column. At the high temperature of the air hydrogen flame, the sample undergoes a combustion. Ions and free electrons are formed in the flame. The charged particles produce a measurable current flow in the gap between two electrodes in the detector. This current is sensed by an electrometer to monitor the sample's elution.